And my name is Leonie Heilbron and I'm a metabolic researcher at the University of Adelaide. So a lot of the work we've done has been in caloric restriction and how this activates metabolic pathways and provide long-term health benefits to people with obesity. But what we and a lot of others have shown that there are a number of biological changes that occur when you lose weight that really conspire against long-term weight loss success. So when we, normally when we're hungry, the levels of the hormone ghrelin, which is secreted from the stomach, go up. And these signal the brain to make us, to feel hungry. And when we eat, these levels are suppressed. Likewise, when we eat, we get increases in levels of satiety hormones, such as GLP-1, PYY, and CCK. And these signal the brain to tell us that we feel full and we stop eating. So when we lose weight, can we just advance the slide, please? When we lose weight, we see that there are increases in the level of the hunger hormone ghrelin and reductions in the satiety hunger hormones to, block or to dampen those feelings of fullness and driving us to be hungry more quickly after we lose weight. We also see reductions in leptin levels as we lose weight. And leptin is another satiety signal that is secreted from the fat cells to signal the brain that we are feeling full. So those levels also drop very rapidly after we lose weight. Leptin is also involved in driving energy expenditure. So when we lose weight, along with a reduction in fat mass and muscle mass, our metabolic rate drops. Uniquely, we have shown that in humans, weight loss also drives people to reduce the amount of physical activity that they do. So by the time you lose around 5% of your body weight, we see reductions in energy expenditure in the order of 300 calories per day, which is about a smashed avocado on toast reduction per day. So the body really has quite a lot of signals that really defend against weight loss. What we also see, though, that this weight loss, it's important to know that even this really short-term weight loss has really long-term health benefits. This has been shown in more than 3 really large trials across the world, in the USA, in Sweden, and in China. These studies are having recruited thousands of people, and this one is from the USA, and they put them either onto a lifestyle treatment where they did physical activity and reduced calorie intake in purple. They put them on metformin or onto a placebo pill. They observed about 7 kilograms of weight loss over the first year in the lifestyle intervention group. And over time, they regained that body weight back to around about the same level as the metformin group, out to 10 years. But what's really important to take note is at this 4-year time point, even though this weight regain had come back, the lifestyle intervention group had a 58% reduction in the risk of developing type 2 diabetes. And this was more significant than the group that was put on drugs. They had a 31% reduction in the risk of diabetes compared to the metformin group at 4 years. They've now followed up these patients for 15 years, and we still see significant benefits and reductions in diabetes risk in the lifestyle group. So something we've been focusing on more lately is really improving health at any weight. So we've known for a long time that shift work and sleep deprivation can induce a circadian misalignment between the central clocks in our brain and the peripheral clocks in our body. And this misalignment is associated with an increased risk of many disorders, such as hypertension, inflammation, insulin resistance and diabetes, some types of cancers, and also fatty liver. So in the last few years, we've begun to recognize that food intake is a driver of this circadian misalignment between our peripheral clocks in our body and our central clocks in our head. And this has led to, if we can go to the next advance the slides piece, this has led to a marked interest in, the timing of food intake or when we're eating. This study was published a couple of years ago now, and they asked people to eat simply consume all their foods in the morning, so between 8 o'clock and 2 o'clock in the day, and they were matched that to the other pattern where they were allowed to eat between 8 a.m. and 8 p.m. So these diets were identical between the two groups. And they saw that the group that ate earlier in the day had improved insulin sensitivity, so reduced diabetes risk markers. They had reduced blood pressure, reduced oxidative stress, and had a reduction in appetite. We've also shown this in another pilot study in our group, where we showed that if you, we were a little bit more relaxed and we let people eat for 9 hours per day. And in one group, they ate between 8 a.m. from breakfast time until 5 p.m. And in the other group, they started eating at lunchtime until 9 p.m. And both of those groups, time-restricted eating, significantly improved the glucose tolerance or reduced diabetes risk markers. So at the moment, these trials really are just at the pilot stage, but they are promising, and they're suggesting to us that maybe focusing on when we eat could be another way to improve health. So we've just started with MRFF funding, a large multi-site trial with Melbourne, where we're going to really get a handle on changing whether what or when we eat is the biggest driver for improving health and reducing diabetes risk.